Okay, for this video, we're going to talk about functions and defining functions to determine whether a relation is a function. And we're going to do that using ordered pairs and graphs and equations. And we're going to talk about some special types of functions, one-to-one functions and onto functions. First, we probably should determine what is a function. Now, a function is a relation, so between x and y, we usually use x and y, in which each value of the domain, which is the x part, gives exactly one value for the y, one value, which is the y. So if an x gives two different values, it's not a function. And we can think of that in a graph form or in number form. We're going to look at it first of all in number form, ordered pairs. So in this set of ordered pairs right here, all 5 of these ordered pairs together, I look at them and ask myself, does any x give two different values of y? If so, it's not a function. Now, when I look at this, I have the x's are 2, 4, -2, 3, and 5. They're all different, so that means this would be a function. That's kind of what we look at. If all the x's are different, we say that is a function. Next one, the x's are 1, 2, 0, 4, and 6. That would be considered a function as well, because all the x's are different, which means there's no x's repeated to give different y's, such as in this one, I see 3 and 3. X is 3, 2, -1, 3. I'm repeating my 3. So when x is 3, I have two different values in this entire relation. So if x's are repeated, we say it's not going to be a function. And the last one here, when x is 1, the answer is 9. When x is 2, the answer is 9. That's okay. But when x is 0, I have two different values. So this would be not a function also. Oh, it's not a function. It is a relation, but not a function. Okay, so we're ordered pairs. We're basically saying, does x repeat itself? And in this case, yes. In this case, is no. So now we look at, I'm going to look at graphs. Now when we look at graphs, we look at these and say, okay, are these graphs going to be functions? We kind of can look at it with eyeballs, thinking of a vertical line. What I like to do is create a vertical line. We do what's called a vertical line test. And I'm going to make a vertical line like this. Let me get that. That's not vertical. Let me make another one. That's vertical. So I'm going to take a vertical line test and I'm going to just move it along. And I'm going to say, okay, here's my vertical line. As I go across the line, a lot of times we use a pencil for this. On a piece of paper, we'll use pencil. We just go straight across. Does the graph ever hit the line twice? No, it doesn't in this one. So this one we will say is yes, it's a function because it never hits twice. Remember when each x can give exactly one y. So each x gives one y. This one, it looks kind of close here, but the implication here is these are what we call asymptotes, where it never quite hits it. So this one would be a function as well, because it never actually hits. The graphing is a little bit off there. At least there's some question in that, but that's what it implies here. Now, this is the one that's not going to be a function, because it's fine here, but when I get to this point right here, I can see for this x value right here, there's two different values of y. So this is the one that's not a function. Well, actually not one of those. This is not a function. We got to look at all of them. It's not multiple choice here. This one here, when I look at it, similar to the one before it, except for the open circle means I'm not including that point. So this one would be yes, it's a function. And when I look at the last one here, I take my thing and I do it, not that one, I want to get this guy. And I drag it across and I say, okay, there's not a function. So that would be because it hits the graph twice, as I can see here and here. So this one I'll say, no, it's not a function. Sometimes we look at equations to determine if it's a function. And the easy way to look at that is we're going to say it's not a function if we have y squared in the function, then it's not a function. If we have an absolute value of y, then it's not going to be a function. Or if there's no y at all in the equation, it's not a function. So because of not having a y, like this graph right here, x equals 4, the graph of that looks like this. So at 4, I have an unlimited number of y values. So that's not a function. So I'm looking at this and saying which one's not a function, which one is a function. This one is not a function. This one has a y squared. That's not a function. This one, we haven't really learned what a sine curve looks like, so we'll come back to that one. This one here, y squared, this is not a function, so by process of elimination, we know this is our correct answer. By the way, we're going to learn this in a couple of weeks, but the sine curve looks like something like this. That's what a sine curve looks like, and you see from the graph now with the vertical lines will never hit it twice. So this is yes, is the function. Now this one, which one is not a function here? So we're looking for the one that has a y squared. That one's not a function. The rest of them all have single y's. That's going to be a function. Okay. Now we're going to look at special types of functions called one-to-one, and those are functions where each x gives exactly one y, but also each y gives exactly one x. So these are all functions because the x terms are all 0, 1, 2, 3. But the y terms here, well, the question for one-to-one function is, do the y terms repeat? And the y terms do not repeat here, so this is one-to-one. Yes, that's one-to-one. 0, 1, these are yes, it's one-to-one. They're all one-to-one functions. This one here, 1, 0, 3, 2, those are all do not repeat, so that's it. This one is the one that's not one-to-one because of the y's do repeat. So when y is 0, I have two different values for x. So this one is the answer to the question because it says which is not a one-to-one function. Okay, and when we do the one-to-one functions with graphs, one of the ways that we like to do this is to do not only do we do a vertical line test, which would be taking a vertical line, but also we're going to do a horizontal line test. So first thing I'm going to do is I'm going to check for functions, whether they're even functions at all. So I take this and I say, okay, is this a function? This one is no, because right here and right here I get two different values of y. So that's not a function. This one is a function. This one, as I go through, I never hit the graph twice. That's a function. This one here is a function. So we've already basically eliminated this one because it's not a function. Not a function. And now I'm going to do the horizontal line test to determine if it's one-to-one. So it has to work with the one-to-one. When I take it like this, I say, oops, wait a minute, I'm hitting it twice. So this one is not one-to-one. Not 1-to-1. And then I continue with the other graphs, and it looks like this one looks to be, I never hit the graph twice here, so that would be the answer to the question. Let's just check this one right there. I can see it doesn't have that. It hits the graph twice horizontally, so not 1-to-1. So which one represents a one-to-one function? This one right here. And the last thing we're going to talk about is onto, one-to-one and onto. So it has to be both one-to-one and onto. So this one here, when I look at this, I say A goes to here, B goes. So that's a function, but it's not a one-to-one. So this is not one-to-one because the y values repeat. If y is 1, I got two different values for x. This is always, first one's x and the second one's y generally. So this one here, is not a function. Because c goes to two different values. So that's not a function. This one here is a function because a, b, they all go to different values. They all have go to no, there's no repeating. Each a goes to only one value. And it's also one-to-one because each y value goes to only one x value, but it's onto means there's nothing left over. Because of this 2, it's not onto. So the last one is the answer that we're looking for. It's one-to-one and onto. Each x value goes to one y value, each y value goes to one x value, and there's nothing left over. Okay, hopefully that helps a little.